Hi everyone, today I will explain about the question 1 in set 1 of the group assignment math for data science. So for the question 1, one way to find out there are significant difference in the average grade between the class A and class B. Step 1 is identify information given. For the class A, the mean is 75, the standard deviation is 8, and there are 40 students. For the class B, the mean is 78 and the standard deviation is 10 and there are 35 students. The significant level is 0.05. For the step 2, state the hypothesis. Now we set up our hypothesis. The null hypothesis, we say H null is equal to mu1 equal to mu2. This means there are no difference between the average grade of the two classes. For the alternative hypothesis, we say H1 is mu1 unequal to mu2. That means there are different of the average grade. Because we're checking both sides, highest and lowest, this is a two-tailed test. For the step 3, choose the correct test. Since the two classes have a different size and the different standard deviation, we use t-test. For the formula of the t-value is t equal to s bar 1 minus s bar 2 divided by the square root of the s1 square over 1 over n1 plus s2 square over n2. Now let's substitute this number. T equal to 75 minus 78 divided by the square root of 8 square over 40 plus 10 square over 35. Then 8 square is 75 and 10 square is 100. So we get 64 over 40 equals 1.6 and 100 over 35 equal about 2.857. Add them together we get 4.457. The square root of that is 2.11. Finally, t equal negative 3 divided by 2.11, which is we get t equal to negative 1.42. For the step 4, find the degrees of the freedom. Because the sample size and the variance are not equal, we use t-test formula to calculate the degree of freedom. After putting the number together, we get approximately 65 degree of the freedom. For the step 5 is compare with a critical value at the 0.05 significant level with a two-tailed test. For a two-tailed test with a 65 degree of freedom, the critical t-value from the t-distribution table is plus minus 1.997. Now compare with 2. Our calculated t-value is negative 1.42, which is smaller than 1.997. So the calculate t does not fall into the critical value. That means we fail to reject the null hypothesis. So for the step 6, make the conclusion. Since we fail to reject H null, we can say there is no significant difference between the mean grade of the class A and class B. In the other word, even though class B average score look little higher, the difference is too small to be statistically meaningful. It might just be a due or random variation. So, for the final conclusion, at the 5% significant level, there is no significant difference between the average the grade Class A and Class B. So that's all for me. Thank you for watching. Bye bye.
Hi everyone, now I'll be explaining question 2 from our Math for Data Science assignment. This question is about comparing the average screen time between two training methods. Group A used method 1 and Group B used method 2. After 4 weeks, Group A recorded an average screen time of 12.3 seconds with a standard deviation of 0.5, while Group B recorded 12.1 seconds with a standard deviation of 0.4. Both groups had 20 athletes and the significant level used in this test is 0.01. First, let's set up the hypothesis. The null hypothesis of H0 states that there is no difference in the average screen time between the two training methods. The alternative hypothesis of H1 states that there is a difference in the average screen times. Next, I calculate the Polish standard deviation, which came out to be the 0.4528. Then I calculate the t-value. To do this, I took the difference between the two means, that is 12.3 minus 12.1, and divide it by the Polish standard deviation multiplied by the square root of 1 over 20 plus 1 over 20. After calculating, the t-value is approximately 1.397. Next, I calculate the Polish standard deviation, which came out to be the 0.4528. Then I calculate the t-value. To do this, I took the difference between the two means, that is 12.3 minus 12.1, and divide it by the Polish standard deviation multiplied by the square root of 1 over 20 plus 1 over 20. After calculating, the t-value is approximately 1.397. The critical t-value for a two-tail test at a 0.01 significant level with a 38° of freedom is plus or minus 2.712. Since our calculated t-value of 1.397 is more than 2.712, it falls in the non-critical region. Therefore, we accept the null hypothesis. This means there is no significant difference in the screen time between the two training methods. In other words, both methods produce similar result. In conclusion, based on these two sample hypothesis tests and the 99% confidence interval, there is not enough evidence to say that one training method is better than the other. That's all for my explanation. Thank you for listening.
Oh my God! Wow!
For question 3, we will be testing whether there's a significant difference in mean caffeine content between the two types. The null hypothesis means that there is no difference, while the alternative hypothesis means there is a difference. Because the alternative hypothesis uses a not equal sign, this will be a two-tailed test. After collecting the data and then putting it in the z-test formula, we will get z-value negative 4.3852, which will fall in the critical region of the graph. Therefore, we will reject H null at alpha equals to 0.05. In conclusion, there is a significant difference in mean caffeine content between the two types. For question 4, we will be using a paired sample t-test to determine if there is a significant difference in weight before and after the program. the hypotheses are H null, means there will be no difference in mean weight before and after, and H1 means there will be a difference. Because the alternative hypothesis uses a not equal sign, this will be a two-tailed test. The calculated t-value will be 4.6014, which will fall in the critical region. Therefore, we will have to reject H null at the 0.05 significance level, and in conclusion, there will be a difference in mean weight before and after the program.